Hello, friends. Steve Delamarter here, along with my friends and colleagues, Ralph Lee in Cambridge and Gary Jost in Gig Harbor, Washington. We're here to present the first of three videos having to do with processing data. In particular, we'll culminate with a video on using spreadsheet filters as a final step in processing data. In this first video, we want simply to talk about the search that we've been on for the last 12 years on how to find the data that tells the stories of textual history. Our approach to this has been not by simply reading a bunch of manuscripts and then getting some impressions and writing humanities kinds of prose. Instead, it's to convert things into statistical forms and create data sets and then draw conclusions from data sets. We discovered that it's simply not enough to create data sets. In the end, it took us 10 operations just to create the first of our data sets, and then fully 16 more operations to process that data. And the main point we want to make in this video is that humanities scholars, at least for those of us that are humanities scholars, we were trained to know that we needed data to support our claims, and huge claims require huge evidence. But we may not have been trained to understand that gathering statistical data is important. Even then, that gathering the data is only the first step in a process. Rather, a statistical data must be processed in lots of different ways in order to give up its secrets, and it often can be processed multiple times and in different directions to find the hidden patterns in the data. Let's talk for just a second here about each of our experience related to data and how to conceive it and how to think about working with to produce it and then to process it. As a humanities scholar, the bullet points you see on the slide here are my experience. Didn't have any understanding about this stuff. Ralph, you were trained as an engineer. Tell us a bit about your experience with this.
Yeah, so I suppose when I came into the study of the humanities, I already came from a background where I was using spreadsheets in particular to process large amounts of data in some research I'd done before, got large amounts of data on efficiency of industries and needed to process it with various sort of matrix algorithms. And those things worked very well on spreadsheets. So I've learned to use the simple presentation of a spreadsheet, but behind it, the analytical abilities that it has.
At some point, you found yourself teaching a course in Bahir Dar University in Ethiopia
I did, yeah.
on using spreadsheets for solving everyday problems. And
Indeed, I developed a course which I didn't want to call computer programming, but wanted to call solving problems using computers.
uh,
So my programs weren't always neat and tidy, but they produced answers. And some of my students from over 20 years ago still use that. They say it's their favorite course. So
Uh, so you came to our project carrying a set of expertises and backgrounds
yes,
that some of the rest of us didn't have. Over time, the value of your perspective began to emerge and infect the rest
yes.
of us, as it were. Now,
Had
Gary,
those moments of sort of we can do this, and it's like, oh yes.
yes, very cool. Gary, you started out, I think, what you'd call a humanities scholar in religion and so on, but at some point wandered into the field of computer programming. How's your story go here?
Yeah, and one of the aha moments for me was realizing the power and speed of computers. Yeah, you can collect things, you can collect data, you can process them by hand, but the sheer magnitude of much of the data really requires a computer to come at it and in creative ways, kind of what Ralph is talking about, thinking in terms of solving problems and not just, oh, hey, look, the computer can do this, it can process some numbers, it can output some stuff. But what are the problems that the scholars are interested in solving? What are the things we want to get at? And how can computers help with that?
So, friends, we've been at this project for a dozen years together, uh, and I wouldn't say we're done, but we've learned a whole bunch of things, and in particularly as it relates to data. And we can take this moment to sort of summarize some of these things. So, the story is going to be about what it took to create the data that ultimately forms the foundation of our statistical universe. And that take 10 full operations to do that. And yet then it has taken another 16 operations after that to process data in various directions to be able to tell the various kinds of stories related to textual history. So first of all, just a quick overview of 10 operations to create the data, and you'll find more thorough videos in other places, particularly in the THEOT workflow step-by-step videos that will walk you through each of these, but we'll just lay out very quickly, review them. So one first set of operations getting ready to create data was to just transcribe text, the same sample of text from 30 to 40 copies of a book of the Ethiopic Old Testament. And then we would take each of those transcriptions, we would aggregate them one after another, and magic happened. When we sorted then that spreadsheet by this verse part number, and voila, it pulled together then all of the manuscripts readings at that particular verse part. But that wasn't enough. We had to then go through and tag each line of each manuscript with a witness number at the beginning and a siglum made up of a shelf mark, combination of shelf mark and date at the end. And still we weren't ready to generate data. We had to align all of the text into columns based on whether or not they share the same root. And that produced this sort of outline, but still we weren't ready to process data because we had to then go and add dots in every place that didn't have. And this was in order to prepare a way in which the computer could grab a hold of the fact that nothing was here and distinguishing it from the something that was in the other places. And still we weren't ready because then we had to add these bars at the front and back to tell the computer between these two bars is where you find the stuff you're supposed to analyze, and this other stuff is metadata that goes along with it. Still, we weren't done because then when we got, and it takes about 40 hours to create one of what we call these dots and bars documents. 40 hours of just shoving lines of text around. Gary developed this script to validate the document. So it takes through and just finds every single problem connected with it before it's ready to run anything. So cleaning the data then was a very important part of the step. And finally, then a first script was developed that still wasn't actually generating data, but it was preparing to generate data. It's the one to identify the word's profile possibilities for each column. And that's simply a fancy way of saying, is the word present or is it absent? That's the word profile possibility. And for every column, sometimes there is no possibility because every manuscript had exactly the same thing. And so the only thing is, yes, everybody's got a word there. But in other cases, like every one of the ones you see on the screen here, there's the difference between a word is absent or a word is present. And if you turn those into numbers, this now is what we do finally in this. Now we have data. We generate data using the information up to this point. We assign the word's profile number to every data point in the sample. And lo and behold, now here we are. This is where we have data that represents the foundation of the THEOT statistical universe when we run this first data producing script on our text. And it's wonderful, and we might have thought, oh, here we are. We've got to the end of the project. We've got a spreadsheet filled with numbers. Here, we've accomplished it. But very quickly, within 4 minutes, we had disabused ourselves of that thought because there are 30 to 80,000 data points in a normal data set. And the meaning of the data is inscrutable. You sit there and just scroll through 1 to 2,000 rows, lines of data with 30 to 40 rows, and you just can't see anything. It's impossible to see patterns in the data without further processing. So for us, it's been necessary across these years to develop these 16 different processes by which we process the data in order to get at certain parts of the story and to pull out certain hidden patterns that are in the data. The most dramatic example of that is with our data set related to the book of Jonah that Jeremy Brown developed for his dissertation, and which he couldn't stop. He had 105 manuscripts in his sample, and there are about 1,500 columns of text for the 4 chapters of Jonah. And that one project alone generated a spreadsheet with 150,000 data points in it.
Well, one of the things that quickly comes into play is a lot of these processes that I've automated with computer scripts could theoretically be done by hand. And I use the word theoretically is if you have 150,000 data points, sure, you could process that by hand. You could compare one manuscript against the other of, the 1,500 points. But the speed at which a computer can do it and the accuracy. We've got pretty smart scholars working on it, but if they're adding up columns, comparing columns for 1,500 rows, of course, it's easy to make a mistake. And so that's the computer processing has been a very valuable part of our workflow.
Yeah, yeah.
Just going to chip in as well in saying that because this data, as it stands, is on a spreadsheet, from my own background and training, I can see that data is inscrutable. But in the spreadsheet, there are lots of ways that can turn it into something else. So it's laid out in a form that's begging to be analyzed. And these are the things that we've discovered, aren't they? How we can do that.
Well put. Yeah. So then quickly, we'll just run through. Now we've got data, but we didn't start to be able to tell stories until we learned how to perform. We'll show 16 operations here that process the data and move us toward beginning to see the stories behind the data or hidden within the data. So first of all, the data is generated in this data tab, and it's this one that has, generally, 30 to 80,000 data points in it. Here they are. The next steps, that data tab, like we have mentioned, is the ground zero for the statistical universe for a project. But processing it in all different kinds of ways is what these slides are about. So from the data tab, we produce this statistics tab, which is a processing of these numbers to accentuate certain things in particular. So how many times do we have evidence of a manuscript being damaged? And that's what this particular statistical tab, some of these numbers tell how many times a manuscript was damaged at a certain point and had no either a 1 or a 2, it got a 0. Or another thing that this one tells is how many times every individual scribe committed an act of scribal idiosyncrasy when there exists a column in which one and only one manuscript has a certain kind of a reading. So all that can be sorted out real quickly with the statistical tabs and answer the questions. Which is the worst manuscript that you don't want to have in your data set? And which is the worst scribe that you don't want to rely on them to give you a good picture? So from the data tab, we also generated this percentages and ratios data, which is the one that tells us the percentage of agreement every manuscript has with every other manuscript. And that is going to become the critical path for several other derivative processes, but still others were based directly on this data tab. So our distinctive readings tool, about which you can see other videos, our best representative manuscripts tool, which is really the result of 4 processing steps to get to that final report. And finally, then secondary and tertiary affiliations tool. All of these things are different ways to work with the same data and begin to see patterns. Producing our statistical file, the one that provides the work order to R, then we have to convert that information, this data sheet, into the comma separated values file so that it can be used to run through our statistical package and then generate this dendrogram. Again, many other videos you can watch that break down the various parts of this, but all of these are operations that part of these 16 operations to process data, including the making the text viewer work, and then these derivative files, which I think, Dr. Lee, have you come say just a word about these, the use of the spreadsheet filters.
Yeah, and I mean, I think again we'll be able to show you more about that in another video, won't we? But I think that these lines show very clearly, in a way, that where we go from inscrutable masses of data, always leading through ultimately to here's the text that really matters, that is distinctive, that shows a particular part of the story that we're trying to tell. And for me, those last steps, once we've got the dendrogram and then the text viewer, and then pulling out the data from the text viewer into spreadsheets that we can then filter, that shows how powerful all these analytical tools are in helping us find the crucial distinctives of the text.
Yeah, yeah. So using these tools and these steps, we've discovered a huge number of things: which manuscripts are most closely related to which other manuscripts, what the major clusters are, where the distinctive readings are found for each cluster, what are the best representative manuscripts for each cluster, how to arrange the text in the text viewer to see the patterns of shared variation and the clusters. Just a magnificent tool for seeing all the facts of textual history right in front of you there. Minority variants in the ETH1 period and their fate in the ETH2 period, and then the new readings of the 17th century. All this stuff, it comes out as a result of one script or another, one processing of data that we've done here. Any parting comments?
Yeah,
Please, Gary.
sure. Well, I'd like to mention what a collaborative process this was of working together. It certainly was not the case at the beginning of the project. We had a 50-page document specking out, hey, here are the 10 manual processes, and here are the 16 computer processes we're going to need. It was kind of one step at a time. You had a manual process, and we said, well, we can turn that into a computer process. You see the output of the computer process. Well, hey, I've got an idea for another manual process.
Yeah.
And just the team working together, talking about what's possible. Yeah, I guess that's what I'll say about that.
Just reiterate that and say how important it is, really, I think, to if anybody's sort of picking up these ideas, to bring together different perspectives and be prepared to just put in the time to listen to people, to work out, because quite often, Gary, you've done something and then we brought it together to a meeting, and then people have said, but now we've got that, we can do this. And suddenly possibilities become alive that none of us had actually thought of in the first place as possible from this data. So,
well, hopefully this lays a foundation then for the next two videos, where you can get right into the very powerful tool of using spreadsheet filters to sort out issues. And Ralph is going to lead us through those next two videos. We'll see you there.